Have you ever heard the term, if something is stupid but it works, it ain't that stupid? Well, recently I have created something so stupid, I think you may reconsider. As you probably know from the title or thumbnail, whichever I end up going with, I have harnessed the power of screenshots. How exactly I use them, we'll have to wait though, until I explain to you what exactly are we doing today and where the screenshots even come in. We are during development of a turn-based strategy game called Primal Fray. Recently, we have done movement with pathfinding and highlighting a moving primal. This was hell incarnate. If you want to see me suffer, you may as well click the card visible on top of the screen right now. Today though, we are focusing on something seemingly easier, which I call an order bar, or a combat tracker. Probably combat tracker is used more often. It is a concept implemented in Horn of the Abyss, mod for Heroes 3, Heroes 5-7 and more recent game instances such as Song of Conquest. It is basically a piece of user interface which tells the player order in which the characters move. It makes planning combat easier, clearer and more intuitive. It is also a chance for me to showcase my full-scale splash arts of primals in combat. In pixel art environment there isn't enough space to show their full fidelity, and the combat tracker would allow me to do it. Now, when you have a base idea, let's go straight to it. First, we need to design it. I imagine it as a row of portraits on either red or blue background. The size of them must be determined by the size of my portraits, so we make a base measurement. I also want a new round indicator between turns. So when all primal move on turn 1, a turn 2 begins. It must be very clear to understand. As you can see, the visuals are quite simple, but what I have also in mind is an animation. I want them all to smoothly move toward the left. The first one on the left will go downwards and show this piece. It will make information of which primal is currently moving visually obvious. When the movement is finished, it will once again hide. The whole row will move to the left again. The last moving primal will vanish, while a new one will appear on the right side. Such an effect seems easy to make, and it almost is. To understand why almost, I will have to walk you through it. Or rather, through two ways it can be done. First things first, I cannot just create all objects and hide the ones outside the order bar. This is because I don't know how long the battle will last. And still creating hundreds of objects just to hide and move them isn't really efficient, is it? Even if I did that, what would happen if a primal died mid-combat? I would have to somehow omit his round every time it is repeated through my hundreds of objects. So that's really not the way. How to do it then? As I previously mentioned, we have two approaches that I thought reasonable enough to even share with you. They differ in ways they move objects on screen. First method is through script, the other is through animation. I will have to explain to you what's the difference and why it matters. Let's go through the script one first, as it is more intuitive, at least I think so. So here's how I would design a combat tracker using script. First, I would create my first 11 objects and tell them what they should display. If you are wondering why 11, that's just how many of them fit in my screen right here, because they have to be pixel perfect. There will be some other UI on the side, but we will work that out in another video. So in each of them, there is either a primal displayed or a round indicator. And if it's a primal, it should be either red or blue. Then, when a new round starts, I will tell each object to move to the left for a certain distance. If the object is first, I would tell it to also become more transparent, more it shifts left. Basically, you are affecting the sprite properties by script, and you are affecting the position, and you are affecting the transparency, so color. But now you can see we are missing an object on the right. That's where the main difference between script and animation comes in. In script, we may create new objects during runtime. We do it with the function instantiate in Unity. So basically we spawn a new tile and tell it what should it display. We make it transparent, but increase its visibility while we move it to the left. Finally, we may destroy the now invisible tile that was on the left so it doesn't take up memory space. I consider this method to be quite intuitive, because each tile is constant. It never changes what it displays since it was spawned. It just moves further and further left until it disappears and gets destroyed. It's a circle of life. There is an issue, however. If a primal dies mid-combat, we have to get rid of each tile displaying him. It calls for further calculations. What if two primals die at the same time because of some AoE spell? Then we have to calculate if the tiles to the right of them should move and how far. It all gets quite complicated because we are moving tiles by script and we have to know how much exactly to move them. So in this case, if we just see that the primal on the left died and we move this tile left, but actually two primals died, we have a problem, right? So we have to cover for such cases. Furthermore, simple moving objects by script isn't very pleasant to do. It is a more technical story for other time. What you should know about it for now is the fact that it's unpleasant enough so that other tool was created. And about that, you all probably know what animations are. In simplest form, they are a series of actions with timestamps, made to display an illusion of often repetitive movement on screen. In Unity, there is a special tool built in for animations, in which we may set them up. It is basically a time axis on which we set actions to take place. We may, for example, say that this primal size should be 1 here and 5 sometime later. When we play it, we may see that the primal is getting linearly bigger between those two timestamps. However, when the animation loops, he is brought back to its original state quite abruptly. If we add another timestamp, which will reduce his size to 1 again, we will create a perfectly looping animation of primal pulsating, or something like that. We may of course change its speed or size difference. In the same way, we may move him in any direction, rotate him, change his color, transparency, and much more. It's a great tool for handling objects in the scene, given one thing: they are absolute. You see, when I want this guy to move, I don't tell him move 100 units to the left. I tell him your next position should be -100. If he is at position 0, he will move 100 units to the left, yes. But if he is 100 units to the right, he will move 200 units. And if he is already on the position -100, he won't move at all. So that means that if we spawn a new tile on the right and wanted to move one tile of distance to the left, we would have to trigger animation, move from position 11 to 10. Then animation to move from 10 to 9, etc. That would mean setting 11 animations just for movement and switching which we are using for each position for each tile. Not an elegant solution if I ever have seen one. So we may do it differently. We may make one animation for all 11 tiles and just move all of them to the left. During that, we may show the 12th tile appearing on the right. We may also show the up and down motion plus disappearing of the first tile, all in one animation. Amazing, isn't it? Well, if you are perceptive, you have already found a flaw in this system. It works once. Just once. Because animations work in absolutes, we move the whole ordeal from fixed positions on the right towards fixed positions on the left. And that's it. If we loop the animation, it just jumps back to the start and does it again. Okay, so where do we go from here? Well, luckily, we are prepared for that. If we just look at the beginning and end frame of the animations, they look almost the same. The positions of the elements are identical. The only difference is the order of pictures and colors. So now we will do some magic. What if pictures weren't assigned to the borders? When the animation ends, we come back to the beginning, but we may change the order by script. So tile number 1 displays the picture number 2, and tile number 2 the picture number 3. Essentially, we now came back to the base state, but have updated pictures. If we look at the animation in game, we can see that we have just our 11 visible and 1 hidden object, not one more. We just move them forward, and then, because they end in visually identical positions to that they started in, we can switch them back to square one while updating the new tiles. This method of tile updating has many benefits. For example, if a primal is dead, he will just vanish, and there is not much work needed to achieve that, as the new data to display is loaded every round. But yes, I know what you are thinking. It doesn't look good. It flashes while the change is happening. While I was making this combat tracker, I deducted that it is impossible to time the change of the animations with the change of the picture displayed perfectly. Think about it. For it to look seamless, it would have to happen in the exactly same frame. If the animation ends too soon, it will first come back to its original position, and only then will the pictures change. If the pictures change first, the bar will effectively display the future for a while before the animation finishes. The differences are minuscule and take only a few frames, but it is enough for the whole thing to flash. Fortunately for us, I have one more trick up my sleeve. Yes, it is a moment you have been waiting for. We're making a screenshot. Think about it. We only need a quarter or less of a second to hide the change happening in the background. If everything goes perfectly, both before and after should look exactly the same. So if we make a screenshot before the change, cut the part from it which overlays just the bar and display it for a quick while the change is happening, we should achieve the seamless transition. Of course, I use the term screenshot colloquially. I don't really mean a Windows built-in function. Instead we'll use readPixels function. It triggers at the end of a frame, so everything is loaded, and creates a new texture by, you guessed it, reading pixels from the screen view. Luckily for us, we may give it parameters dictating what part of the screen it should read. So we give it the thin slice of the screen where the order bar is, and we're golden. We now create a sprite of exact same size and exact same position as the screenshot takes place, and then we display it inside of it. We may just hide and reveal the sprite when we need. It works perfectly. So how is it? Is it not stupid because it works? Because I love it with my whole heart, while thinking it is crazy stupid despite that. It is just so unconventional and weird that no one expects it to be part of the game functioning. To be honest, I'm not sure if it's perfect. It is for sure a little bit taxing, as the readPixel function is invoked by the CPU and not GPU. However, it happens only once a turn and not every frame. Plus, I don't have to spawn and destroy objects, which I would have to do if I use the other approach. Game development is a game itself, you know? A game of choices. Everything you imagine can be somehow done. Sometimes easier and sometimes harder, less or more efficient. Today's decision blessed me with game taking screenshots of itself to function, and I wholeheartedly love it because of it. Would you choose this approach? Or maybe you would do it by script? Possibilities are endless, and you may let me know which one you prefer in the comments. So I guess it's all for today. Next time I'm going to take a break from coding and make some more drawings. In particular, a new biome. If you would like to see that, smash that sub button. Until that time though, cheers!